Okay, let's dive right into this. Welcome to a really intensive, highly focused error analysis workshop designed specifically for your Cambridge Computer Science exams. Now, to kick things off, I want you to think of yourself as a professional photographer for a moment, right? A photographer doesn't just point a camera at something and randomly click the shutter. No way. They find the perfect angle, they consider the lighting, the background, and most importantly, they frame their subject to highlight exactly what matters to the story they're trying to tell. Well, guess what? That is exactly how you need to approach your exam answers across syllabus codes 0417, 0478, 2210, and 9618. It's not just about knowing the facts, it's about framing them. Today, in this explainer, we are going to learn how to frame your answers to highlight the exact key evidence the examiner is desperately looking for. We'll be looking at a really common pitfall area, binary and denary number systems, but we aren't just here to relearn the basic theory. You already know that stuff. Instead, we are going to analyze exactly where smart students go wrong, why they lose marks, and precisely how to fix it. Get ready, because we are completely upgrading your exam strategy today.
Here's a quick look at our diagnostic journey for today. We're starting with the memorization trap, then moving into the anatomy of exam mistakes, followed by the specificity rule, the 3-pass strategy, and finally, our 4 prompts for success.
All right, Section 1, the memorization trap. Knowing the theory but losing the marks. Let's break down why this happens.
Every single year, without fail, highly confident students fall straight into a massive trap. They memorize that binary is base 2, they memorize how to convert denary to binary, but they completely fail to apply it when it counts. Let's look at a realistic baseline task you might see from syllabus 0417 or 0478. The question reads, a school uses an embedded system for its smart security gates. Explain how binary and denary are used in this context. Now, pay very close attention to the phrasing here. It's asking you to explain its use within a highly specific real-world digital scenario. It does not ask what is binary, If you just write down the textbook definition of binary, you're missing the entire shot. You absolutely must link the core concept directly to the process taking place at that specific smart gate. You have to move your brain from basic recognition to deep understanding and critically to real-world application. That's what separates the top grades from the rest.
Okay, let's put on our examiner hats for a second and analyze 2 flawed student answers side by side. I want you to really look at these. On the left, we have Alex. Now, Alex falls right into the memorization trap. His answer just overloads the page with raw computer science facts. He lists conversion tables, he talks all about base 2 and base 10, but guess what? There is absolutely zero analysis of the smart security gate. He essentially dumped his memory onto the page without framing the subject at all. Then, on the right, we have Sam. Sam's problem is different. Sam rushes the response, writing a really vague sentence about how computers just use numbers to work. Sam totally misses the command word requirements. Neither of these students found the right angle. Alex used the completely wrong lens. He focused on textbook facts instead of the scenario. Sam didn't even look through the viewfinder before snapping the picture. The image is entirely blurred. They both completely missed the core idea, which was to clarify the specific digital problem that binary solves in this exact hardware context.
Moving on to Section 2, Anatomy of Exam Mistakes, Decoding the Demand. This is where we change how you read a paper.
Look, answering correctly has to start with treating exam questions like a complex puzzle. You cannot just pick up your pen and start writing the second you see the word binary. You need to decode the demand of the question first. You have to diagnose exactly what the task is testing before your pen even hits the paper. Are you confusing memory with storage? Are you listing features when you should be evaluating? You must understand the Cambridge assessment objectives. Think of every single command word as a specific lens for your camera. Is the question asking for a process explanation? Is it asking for hardware and software selection? Or is it testing your logical reasoning? Here's the harsh reality. If the question asks for an evaluation, but you just provide a description of the system, you get 0 marks. Decoding that command word is step 1 of the framing process.
And this brings us to the ultimate computer science success blueprint. This is the exact structure top students use to build answers that examiners absolutely love to give full marks to. We call it the Peel framework. Here's how it works. Step 1 is the point. You state your main idea clearly and directly. Step 2 is evidence. You bring in a specific technical detail or terminology straight from the computer science syllabus. Step 3 is explanation. You detail exactly how the process works in a clear, logical sequence that another learner could actually follow. And finally, step 4, which is honestly the most critical part, the link. You must anchor your explanation firmly back to the real-world scenario given in the question. This structured approach forces you to explain the inner workings of the process and then literally connects the practical consequences back to the user or the system on the page.
Let's actually see Peel in action, side by side. Look at the massive difference here. The generic fact says binary uses ones and zeros. We see this all the time, but that earns virtually nothing. Now look at the Peel answer. The smart gate uses binary, boom, that's the point. To process sensor data, there's your technical evidence, because the CPU only understands logic states. That is the clear, sequence-driven explanation, ensuring instant security responses. And there is your link, anchoring it directly to the context of the gate. It's literally night and day, isn't it? Which answer would you give the marks to? Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Awesome, let's keep building. Section 3, the specificity rule. I like to call this the context anchor metaphor.
Real-world transfer is what actually earns you those top-tier marks. Read this stark, real-world examiner insight with me. Examiner-style performance depends on specificity. Generic responses rarely gain full marks. Let that completely sink in for a moment. If you write an answer that is so broad it could apply to any computer system in the world, it is way too vague. Yes, the underlying theory applies everywhere, but in your exam, it only matters how it applies to the exact scenario sitting on the page in front of you. Whether the exam is asking you about smartphones, dynamic websites, school administrative systems, industrial control, banking networks, or robotics, your answer must drop a heavy anchor directly into that specific context. Your terminology must be razor-sharp, precise, and completely localized to the problem they gave you.
So let's do a live rewrite checkpoint right now and transform Alex's red pen errors into green check marks. Remember Alex's answer from earlier? He just dumped a bunch of binary conversion facts onto the page. To fix this, we need to take his isolated facts and anchor them directly to the school network scenario. Instead of just saying binary is base 2, which gets us nowhere, we write the school's smart security gate relies on an embedded microprocessor. This processor evaluates access card data as binary signals, where electrical pulses represent base 2 logic states. Do you see what we did there? We took the pure theory, the raw computer science facts, and we framed it perfectly within the context of the physical hardware at that school gate. We mentioned the microprocessor, the access card data, the electrical pulses. This is exactly how you maximize your mark potential.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, welcome to the interactive workshop segment of our explainer. I want you to engage directly with the screen right now. We have a 60-second visual countdown starting. I want you to scan this complex computer science data table. Your challenge here is to quickly classify the core elements before you would even begin to write an answer. Find the data type, identify the hardware involved, pinpoint the exact computational process, and check the overall question context. In computer science exams, catastrophic mistakes frequently arise when learners confuse these foundational elements. You know, things like mixing up a compiler and an interpreter, or confusing social engineering with malware. Scanning and classifying your data like this first, it stops those errors dead in their tracks before you waste 5 minutes writing the wrong thing.
Let's move straight into challenge 2. I want you to be the examiner for this one. Look at the flawed paragraph on the left. It attempts to explain how data is handled, but makes a classic, painful error. It confuses memory with storage and protocol with service. It's just naming a device without explaining how it actually works in the system. Now shift your focus to the corrected paragraph on the right. Notice the incredibly precise terminology. It shows a correct, logical sequence that another learner could easily follow. It distinguishes between nearby, similar concepts beautifully. Identifying the exact sentence that is losing marks due to confused terminology is a superpower you need to develop. When you can spot it in this text, you'll start spotting it in your own rough drafts.
All right, challenge 3. The pressure is really on now. You have exactly 30 seconds on the clock. I want you to mentally draft or quickly jot down on some scrap paper one perfect, highly specific Peel paragraph explaining a binary manipulation error within a retail barcode scanning system. Go! Remember, point, evidence, explanation, link. Don't just give an advantage with no reason. Don't describe a technology that only sounds related. You absolutely must explain how the binary error impacts the retail system specifically. Does it scan the wrong price? Does the database fail to update? Time management in these exams is a matrix you have to master, and speed framing your thoughts using the Peels framework is the ultimate key to unlocking those top-tier grades under serious exam pressure.
Fantastic work. Let's move to Section 4, the 3-pass strategy. This is your ultimate revision cycle.
So, to prevent these common errors from happening in the first place, like vague wording, missing process steps, or failing to answer in context, you need a layered study methodology. A strong revision cycle isn't just passively reading your textbook over and over again. It's a strategic process. Let's walk through these 3 passes. Pass 1. Secure your key definitions and contrasts. You must deeply understand the difference between validation and verification, or denary and binary. Pass 2. Rehearse explanations and diagrams. Get a whiteboard and actually write out the sequences and draw the logic circuits from memory. And pass 3, which is honestly the most important, focus on exam adaptability. Practice taking the core theory of binary and applying it to a secure communication scenario one day and a media processing scenario the next. Adaptability is everything.
And that brings us perfectly to our final section. 4 prompts for success, the memory structure.
This right here is the final piece of the architectural puzzle. It's a diagnostic checklist you should use in your daily revision and, crucially, as a mental checklist before submitting any answer in the exam hall. Ask yourself these 4 prompts aloud. Number 1, what is it? Define the technical concept clearly. Number 2, how does it work? Explain the computational process step by step. Number 3, where is it used? Connect it directly to a real digital problem or scenario. And number 4, why is it better or worse than an alternative? If you can confidently answer these 4 prompts, your knowledge of binary, denary, or literally any other topic in the syllabus is fully anchored and examiner ready. If you stumble on any of them, you need to go back and rebuild the topic using a worked scenario-based example.
So let's summarize the rules that guarantee those top marks. This is your complete computer science answering system. 1. Command word decoding. Always diagnose the demand of the question first. 2. Peel framework application. Structure your response to provide evidence, explanation, and a solid scenario link. 3. Time management matrix. Use the 30-second speed planning technique we just practiced. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I want to leave you with a final thought to reflect on today. Finding the perfect angle requires knowing exactly what you want the final picture to look like before you take the shot. So, what is your target grade for computer science, and what is the biggest challenge you are facing right now? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.